MCQ 13 is another chemical energetics question, but this time around more towards the usage of your Gibbs energy formula. So over here, we are looking at the decomposition of hydrogen peroxide to produce water as well as oxygen gas. The issue over here, however, is that for several weeks, there have been very little decomposition. We're trying to investigate what could have been the likely case for that. So a lot of first instance here to show that there's a low visibility, we can straight up infer that the delta G is perhaps going to be positive, or the activation energy is high. So this is some of the initial kind of observation that we can actually get from that. Now, however, let's get things into perspective. Delta G is equals to delta H minus T delta S. Now we know that delta H itself, as per given in the question, is actually negative. The magnitude does not matter. But what is actually crucial here is to take a look at the starting state symbol of the reactant as liquid, but it became liquid as well as gas. The inclusion of gas as a reactant could only indicate that we are now looking at a positive entropy because the system is getting more random at the end of the reaction. And knowing that temperature itself cannot be negative, it can only be positive or zero. That means that if, let's say, we're looking at the positive temperature over here, the back function of negative T delta S will actually be negative. So with this being mentioned, negative and negative will show that delta G, irregardless, will always be negative. So if you take a look at number 1, mentioning that the Gibbs free energy of the reaction at 20 degrees Celsius is actually positive, this is actually not going to be true, because if you sub in 20 into your T, is it going to be a negative function at the back after being multiplied by your positive entropy? So number 2 is probably going to be our best bet in trying to discuss why this reaction is so slow, because of the abnormally high activation energy that cannot be accounted by delta G. And lastly, when talking about entropy change represented by delta S, it has been mentioned that the production of gases here increase the randomness of system. And the increment of the randomness of the system will show that the entropy is not going to be negative, but rather it should have been positive. In this case here, the only correct option to describe this case would have been the high activation energy, suggesting that option D is the correct answer.